A very good day. Goedemiddag allemaal. Welcome to this TNO webinar about solar energy in Brabant, building sustainable future for Europe. My name is Veronique Gevaerts and I will be hosting this webinar for you today. A very special word for our Dutch listeners. Als u interesse heeft achteraf, ongeveer een week na vandaag, zal deze webinar ook Nederlands ondertiteld beschikbaar zijn via de website tno.nl/solar. And I will switch back to English again. I'm here together with colleagues from different companies. So actually on my right side there is Paul Gosselink from the BOM. We have Ronald Volbert from Heijmans. And on the other side we have Roel Rennen from Aldoa. And here are their names and pictures again if you don't recognize them. Well, in this webinar we will start with the agenda for Ronald. We will start with the discussion from Heijmans and their view on what are the company needs for making buildings. Right? So everyone in the Netherlands knows Heijmans and they build companies, but a lot of other things as well. Ronald will say something about that and what they need and what their vision is for the energy and supply within those buildings. Next up is Roel Rennen from Aldoa, who will say something about how this technically can be done already and what they are doing from their side as building suppliers or suppliers of building materials. Next up is Paul Gosselink from the BOM, who will tell something about the ecosystem in Brabant and how the vision of the BOM is with respect to making PV and manufacturing of PV in the Netherlands and Brabant specifically. And then in the end, I will tell you something about the technical status at TNO and where we are right now with mass customization technology and flexible perovskite PV. Some small notes on this webinar. This is an interactive webinar, which means that you can actually ask questions. And the questions can be put in a box on the bottom of your screen, the right bottom of your screen. So please feel free to answer or to ask questions. We will try to answer a couple of them during this webinar, and all the other questions will be afterwards answered either by email or by phone call. So please leave your credentials if you would like us to contact you. And from that point, I would like to wish you a lot of energy and a lot of enjoyment in this webinar. And I will give the word to Ronald Volbert from Heijmans Energy, who will tell you something about their vision on the built environment.
Welcome, my name is Ronald Volbert and I'm working by Heijmans. And with my yellow heart, I want to tell you something about a healthy living environment. It's a new strategy what we have, and especially since 2018 is energy a main part of it. Thanks of Erik Wiebes, we are changing, our energy system is changing. Something a little about Heijmans, for the people we don't know. We are a listed company and that combines activities in building technology, in working for utility, in the infra, in the connection. So we connect everything from A to B, so well for asphalt, but also for pipeworks and cables. And since 2018, we have energy, and I'm working for energy. And with that yellow heart from energy, we have several bold statements, and that bold statements, that's our vision and strategy for the future. I don't tell a lot about it, only two small things, and that's something about sustainability and about how we make the connection. And about sustainability, there is a reason. We want to give more than that we take, and for that reason, in our energy department, we need more energy. So building integrated PV is a must for the future. And how we do that, I come up at later on, also in this presentation. And therefore, we need for all the connection, and that connection, so that we can take together, also with you, a step forward. And for me, as Heijmans, we want to make a shift towards to a sustainable leader. But what's the reason? The reason is that we want to make impact. And that impact is about the network, over the financials, and also about the sustainability. And I want to tell you something more about it, a little more. And that's the transition, the energy transition. We are changing from a fossil to a natural gas-free environment. In the past, the epicenter was only on the gray, on the left side on this slide. And we are now changing to the right side. And in the purple, you see the steps. Since 2018, from my perspective, we are changing from a central network more to a region. And for the number 3, it's more in the area what we built for. So there are more districts. And we are building already energy positive houses. And in the future, we should also build positive energy districts. And therefore, we need PV more in our area. That's the reason what we think we should make more impact together with you. For that reason, the building integrated is something what we need because we don't want to load the network. Financially, it's something for the consumers, it's also important. An issue is still the regulations, and that's the main, but it's coming in later in this presentation. And to be sustainable, it's also necessary that we make, also in the Netherlands, local building integrated PV. So the people can lay out down in their chair and enjoy. So what we like as Heijmans, we take care of each other and make sure things get done. So together we make it happen. It was a short notice. Later on, more technical information. But I want to go give it through Roel.
Thanks, Ronald, for your vision on what needs to be done within the built environment. And I'm very happy to hear that Heijmans Energy is...
Yeah, it was briefly, but...
It's good to know that you're very, very committed to this topic. Having said that, to be able to build, or for Heijmans to build houses of the future and have a building integrated PV there, of course there's a need for suppliers that actually make this building integrated PV. And that part will be covered by Roel Rennen from Aldoa, who will tell us a bit more and insights from his company.
Okay.
Please.
Good afternoon. Indeed, I would like to tell a bit more about the current situation of BIPV business in the Netherlands, especially. With all the available products, commercially available products, and we'll emphasize on the challenges we have and what the building industry would need from the solar industry to come up with so that we can accelerate and implement BIPV more often. So to get started, although as a construction company who builds facades, you can see at the pictures below that we emphasize on, at least in the past, we emphasized on metal facades. The challenging, the better for us. But we see, of course, with the needs from the global warming and everything else that's happening these days, that we strive to minimize the environmental impact, not only of our own facility, but also of the facades we develop. So, of course, we have solar modules on our own rooftops. We have a heat pump installed. We have a fully electric car park. But more important is that we, together with our suppliers and our subcontractors, we aim to develop sustainable facades, the most sustainable as possible. On top, we believe that the facade of the future will not be a cost, but will have a profit. So every surface that we develop should be able to generate electricity, or maybe you could harvest warmth or cold from the facade. And these developments we combine in Aldoa Green, which is a separate division of our company. So first, to give you a picture of what's available these days in BIPV products. We see a separation of two different kinds of facades that you could make. First, of course, a standardized black, usually framed module you could implement. But of course, that has its limitations on size, on aesthetics. luckily, we have the option to fully customize our BIPV modules. So we have a toolbox where we can pick from. We have different cells. We have a crystalline. We have half-cut cells. We have IBC. You can think of curving, thin film cell technology. And that we can combine with different types of glass. We can change the position of the junction box. We can play around, in all sorts of directions. Even to going to a triple glazing with cells in between. As you can see, I will guide you to some aesthetic options. You can add some coloring to it. So this, for instance, is a metallic type of color that can be observed from one angle. It should be very bright, and the other a bit more dark. You can think of patterns on the solar modules to full images created by dotted patterns, or this is the most extreme option. There, where's a fully full surface print, a photorealistic print with a structured top glass, so that it imitates actually another type of product. So to give you an example how it could look, these are projects state of the art. On the left hand side you see triple glazing, usually on these atria applications. You have a full image and a sort of a Corten look at the right side. So I would like to give you a bit of a background what we face in our building industry. There's a few main drivers for the BIPV market these days. We come from, let's say, 10 years ago, when there were only a few projects being realized. There was not a real demand for solar in the facade because it was very expensive. Now these days, there are a few things that help the solar market a lot more, because we have regulation in place. The BENG regulation, bijna energie-neutraal gebouw, or near zero energy building, which demands, especially for office buildings, 50% of the total consumption of energy should be covered be generated on the building itself. That's not only the electricity, but also the warmth or the cold. Together with the elimination of natural gas, as already Ronald explained, there's an extra demand for electricity to power the heat pumps that we need to install. So the combination of these two, of course, you can demand for a lot of energy on production on the building. And of course, if you look at terraced houses, low-rise, you can, of course, cover the rooftop and that's it. But if you go if you build higher buildings up to 5 stories or higher, you definitely cannot fit the solar modules on the roof anymore. So you'll need to place them vertically in the facade. Other regulation says, especially for innovation, it's interesting, office buildings will all need to have a label C, an energy label C, for renting out their places. Otherwise, they cannot earn money. So at this very moment, only 60% of the office spaces is up to that level. So we see a huge demand for extra PV installations in future. On top, the PV price, so the production price of PV is still getting lower and lower, especially if you compare it with other types of materials you can use for a facade. To get a full picture of what's happening in the market, this is also very important. So because of the PV modules being installed over the last period, we see that, of course, there's a peak on production in the middle of the summer, at noon, you see a lot of PV modules pushing back their electricity to the grid. This is causing a drop of the energy prices on these specific moments. And on the other hand, of course, we have a lack of energy in the winters and on the moments that, well, let's say in the evenings and in the mornings. So if you look at the top left image, you see that development. And if you then compare it with the energy consumption of, in this case, office buildings, at the bottom left side, you see that there's an extra demand for electricity in winter situations. Of course, that has to do with the extra power that heat pumps will need. If you then translate that to BIPV compared with rooftop installations, you see these two graphs at the right side. In the summer situation, yes, there's of course a lot less energy being generated on the facade. But if you then realize, of course, the energy is worth, well, very, very little, or even you get nothing for your energy, it's not that very interesting. Where, and on the other hand, in the winter situation, you generate a lot more on your south facade if you compare it with a rooftop installation. And that's, of course, the challenge. We need to focus on to match the BIP or the generation of electricity with the consumption. And BIPV is perfect for that. Another challenge, of course, is the cost price of BIPV. But I've tried to explain it in this graph. We are, moving in the right direction. So if for the standardized solar modules in the facade, we are coming close to, other types of facade materials. And if you then realize that already installation of an inverter is included in this price, you can imagine that we're really getting close. But indeed, still, the fully customized modules were far away from the prices that we need to compare with other types of materials. If you, could think of the situation where you replace a other type of facade material with a standard solar module, so you actually could deduct the price from the solar installation from the original facade, then you can think of a return on investment of 2 to 3 years, which is already quite a no-brainer to me for installing solar modules compared with other materials. If we then look at, an add-on panel, of course, so you have still the cost for your original facade and you put on top the cost for a standard solar module, then this ROI is a lot worse. And then again, to do the same calculation for BIPV, of course, replacing the material, so deducting these costs, we're facing 15 to 22 years these days. And of course, yes, there are a lot of side notes to be made with it. Other challenges we face, this is a very important one. Basically all materials have their shadow costs. That means from production, mining, production, or creating the product, including transport up till recycling it, they come with a certain CO2 emission. And actually, PV is one of the worst you can get. The production of cells, of crystalline solar cells, is very energy intensive. So that's a real challenge. So you can see here, of the total budget of a standard office building, for instance, almost 25 to 35% of the budget, the total budget for all the products that are included in this building, will come from a PV installation. And that's only the essential PV that you need to reach the BANG norm. So it can be even a lot more. Then there's this, well, of course, other obstacle that is creating this high shadow cost, and that's because the cells or the modules themselves cannot really be recycled in a commercial way these days. So then I come to the conclusions actually, and describe the needs what we would like to have for our building industry to accelerate. Of course, we would like to have a lower cost for BIPV modules, that's for sure. How you can achieve, of course, you could think of lowering the price by robotized pick-and-place machines and to create custom-sized modules. Or you could think of cutting products on site or integrating or production of semi-finished products that we can easily implement in other construction materials. Yes, of course, you can think of the traditional building materials as it's shown at the bottom, but you can also think of completely new types of products, and I challenge everyone actually to come up with them. And of course, yes, what I already mentioned, of course, the shadow costs are a big issue. So changing to a more sustainable way of producing solar cells, other types of cells would be very helpful. And of course, if we could recycle them, well, that could as well help a lot.
Thanks a lot, Roel, for this inspiring talk. So we can actually see what's already possible, but also that there's quite a number of technical needs still to be addressed. I do have a few questions from the audience. So I would like to start with a question for Ronald. So one of the questions is, what do you think is needed to make sure that BIPV is used from an economical and technological perspective?
Oh, I think Roel mentioned already in the latest sheet. So the cost price should also go down, but also the regulation, and especially to make it happen, we need products because we are building it, and we need products what we can use and what we can introduce in the sector. So we need products, and then we can build it.
Yeah. So cost
and products.
Products.
Yeah.
And go.
That's easy.
Take action.
Yeah,
well,
take action. Yeah.
Take action, yes. Okay, very clear. And indeed, you mentioned quite a number of things already, Roel, in your presentation. Then we have another question from the audience. And I think that's for you, Roel. How does BIPV compares to an east-west rooftop installation?
That's a good question. Well, we've run these simulations, and you still see that there's limited production in the winter situation, because in usual east-west orientation is a limited slope, so up to 10% or 10 degrees actually, and the sun is in a very shallow, very low angle actually. So it barely hits the surface of the solar modules. So actually a south-oriented solar module on the rooftop performs better than an east-west in winter situation. And that's the challenging. So we need to focus on the winter situation.
Yeah, that's very clear. Winter situation is most important, especially with the electrification of all the other elements. Definitely, as also mentioned by Ronald. Then I would like to thank you for the answering of the questions. And we move forward to Paul Gosselink from the Brabantse Ondernemingsmaatschappij to say something about the political and economical aspects for PV production in Brabant.
Okay, thank you, Veronique. Good day, everyone. I would like to tell you something about the solar industry. We want to take back to Brabant, the Netherlands, and we have taken a regional approach, and that fits within the Resilience and Repower EU strategy, which is in place. First, something about the Brabant Development Agency, the BOM. We are there with 9 other sisters in the Netherlands as a private company, but with 2 public shareholders, the Ministry of Economic Affairs and the province of Brabant in our side. located in the southern part of the Netherlands, with its main goal to strengthen the Brabant economy, let the companies be prepared for the future, that they have a business case also within 10 years. We do that with 3 departments. I'm from the ecosystem department, we'll tell a little bit later on. But also we have a venture capital fund and a project fund, total about 350 million euros, investing in companies and projects. And we have an acquisition and trade department helping us to create the best ecosystems. And we work from societal challenges combined with the strong industrial sectors in Brabant. For example, about healthy aging, as low as possible health cost, also for elderly people. And we have, for example, a pivot park in the northeast part of our province, developing new kind of trucks to support this. And I'm working within the societal challenge zero carbon, the green energy transition, and within that green energy transition, of course, it's a worldwide development to reduce CO2 emissions. We look from an economic perspective, and from fair SWOT analysis, we look how we could develop strong clusters that could be competitive with new kind of products. I'll tell you a little bit later on. About 13 years ago, I think the province of Brabant, together with TNO and the Energy Center in the Netherlands, joined forces, and at the high-tech campus in Eindhoven, Soliance was erected, focusing on thin film solar R&D. And within the same period, you could say, from silicon PV, the Chinese industry grew, and with the several 5 or 10 year plans within the Chinese government, within 5 to 10 years, the Chinese took over and are by far market leader in silicon PV. And the province said to us, well, we had 13 years ago the idea setting up a focused R&D on silicon PV, and with the high-tech industry we have, famous I think all over the world, we thought we could at least do some development and sales, marketing, sales and production of equipment to produce solar PV panels, but well, that failed. Within the new TNO strategy, and also that something by Roel Renner of Adoa and Ronald Volbert of Heijmans, we saw that there are some new opportunities, focusing on what I call it a smart specialization strategy. We won't compete and we won't defend the Chinese, I think, on silicon PV, but within the zero carbon emission ambitions there are, and not having a food for energy discussion. I think there are, and the TEGI Urban Energy did some research on it. There are a number of options, for example, the buildings, as Ronald and Roel already said, with regulations, there is more need than only the roofs, but also highways, automotive sector. There are a number of possibilities to develop and use them as energy producing elements, and that was what we set up by the regional government together with TNO, and Veronique will tell a little bit more about the research later on. We set up what we call the Innovation Coalition, and we want to involve the Dutch and the Brabant high-tech and tooling industry together with the energy producing industry to create a new generation perovskite, flexible perovskite production industry. And we have the ambition within Resilience and Repower EU to set up a new facility together with with the markets, with the building and the construction suppliers, and with TNO and with the machining industry to set up a new production facility and have a good market share. In order to learn from what went wrong a number of years ago and where the possibilities are, we use what we call an ecosystem model, derived from research done by Erik Stam from Utrecht University and also work by Mr. Raspe from Planbureau voor de Leefomgeving. And we are looking towards the ecosystem within the challenge we have defined to develop a new thin film PV industry. In the up above, light blue, you see the entrepreneurship and the innovation elements. In the dark blue, you see the elements around the services you need. And in the left down in the mid blue, you see the elements around a stimulating environment. And what we did is a bit of a SWOT. In red, you see the elements we are lacking. And in orange, you see some elements that should be improved in order to have a good surviving industry. Of course, talent. As we all know, there is a lack of skilled people, and we have, for example, also a big health and a big semicon industry. So to set up a good thin film PV industry, well, you should have a production as much as possible automated and robotized, and also what Roel said, that could give help to lower down the cost price of the product. But we also looked at networks and clusters and also leadership. We have a big high-tech industry in our province, but the focus is within high complexity, high mix, low volume on semicon and health. And a number of companies have experienced the failure in supplying equipment to the silicon PV industry. So we had to convince them that energy technology, and especially thin film PV, could be of potential benefit to them, and could be also a potential business case. And another one you see in red is on the finance side. It's also in America, for example, but also here. There is Repower EU, but the first factory and the first products are always the most expensive. And there are a lot of risks, especially also in the thin film PV. And you see that for this kind of new facilities and production processes, it's very hard to convince all kinds of venture capital and banks to invest in this kind of new technology. So we have to develop and as convincing as possible a business case that could help to convince investors to invest in this kind of technology. So within this ecosystem analysis, we set up a program to develop a regional approach combining the thin film perovskite production cell and the equipment industry. Veronique will explain later on a bit more on this production process, but it is in 3 steps. First, you have to produce the perovskite, the flexible perovskite cell in rolls. And as Roel said, shadow costs should be taken into account. Some LCA life cycle analysis has been made, and it's only 40% compared to the silicon production of PV cells. So, and it is recyclable. So we think we have here a competitive advantage. Those cells in rolls could be sold, for example, to Solarge, an upcoming company doing very well, producing lightweight energy systems for roofs, for example. Now they buy Chinese cells. These cells, these rolls, could be bought by them, and then they have a complete European product, for example. But it could also be laminated. That's the second step, and then you have a combined product that could be used by Aldoa in their facades, for example, or could be used by Heijmans going to meet the regulation demands. There are some challenges on the material side, but also on the productivity, and we set together the companies to develop this a full-speed production process, and we think within 2 to 5 years we can have a 1 gigawatt production facility in our region up and running. And then, in the meantime, together with the companies here, we want to demonstrate that it's also working. This is a little bit about our regional approach. Not doing alone. Veronique and her team, with Stuart Veenstra and Peter Toons, we are working both on the production, the industrial research and getting ready for production, but also in the application side. And I have some expertise from outside, and a colleague from Ventures who is setting up with me the business case for the new company that should be on its own feet next year. If you have interest to join our ecosystem, well, just send an email to me and we get in touch. Thank you.
Or you can use the buttons on your screen that should have appeared automatically. Thank you, Paul, for this overview and the vision of the BOM for the complete ecosystem for making PV manufacturing. And there's actually an interesting question about this ecosystem from the public. The question is, are there initiatives to include raw material producers and recycling companies to cover the complete value chain within the region?
Of course. The very nice thing is that compared to the raw materials for silicon PV, the materials for the perovskite can be found in bulk in Europe. So it would be very nice to have them in place and work together with them on the right recipe and the recycling also of the perovskite. And the same as, for example, as Solarge. It would be very interesting to have the recycling companies, because the product, the laminate and the perovskite, could be reused very easily. Yeah, well, we are very open to integrate them and have a fully cycle.
Okay, I have one more interesting question, and I'm not sure if you want to answer the question because it's quite politically sensitive, but if anyone can answer it, it's you.
Okay.
So this question is, how do we prevent that technology developed in Brabant doesn't end up in China?
That's a difficult question and a very good question indeed. I don't think you could avoid that it will go into Chinese hands. So we discussed a lot. We spoke with several European companies, with American, with British companies, and we were convinced that we have a good strategy. They see it as the same strategy for smart specialization. And what we learned also from them is you have to build up a good IP portfolio. And we think there are chances also from the technology side. And the other advantage is that the Chinese are right now focusing on heterojunction and on fixed PV, as they are market leader in it. So it's not right now in their interest, but and we should use that within the next years to build up and enlarge the advantages we have right now, but they're welcome. And the other advantage we have, I think, to the Chinese is that, well, you combine this product with the products of Aldoa or with roof, with tiling companies. So you can produce on an order basis, and that you can assure short lead times, and the Chinese won't be possible to do that. So you should use that competitive edges, I think, advantages to have still a voorsprong.
You'll be a step ahead.
Step ahead,
Definitely.
yeah.
Yes.
Use that as a step ahead, because
So-
you can't avoid that it will be also in their hands.
Yeah. So we will try to keep ahead of everyone else within Brabant, within the Netherlands, ahead of the entire universe maybe. Thanks, Paul, for answering this very sensitive question.
Okay.
Then I would like to move on to the technological part. I was requested to cover the topics of mass customization and flexible perovskite PV. Of course, this is not all my work, but a lot of my colleagues are involved in making these things work. I am a technologist from background, and I still am allowed to do once in a while some things in the lab, just for you to know, but definitely this is a team effort. The pictures that you see here in the, maybe I should say first, please feel free to ask questions still in the chat. On the bottom right of your screen, you should be able to ask questions, and that will be reverted here to the studio, which I have here just under my eyes. First, I'll tell you something about the technological status. So this webinar is hosted by TNO, and as you know, TNO is a knowledge provider, but we don't develop knowledge without a reason. So we do this together with partners, together with the industry, and we very much believe in the local production and local use of PV products. As Paul also said, that's one of the advantages that we can definitely have with respect to the worldwide market. The images that you see here on the top side is a roll-to-roll produced and laminated PV foil of perovskites. So all the layers are roll-to-roll coated, that can be roll-to-roll coated currently, which for the technical people amongst us means that currently there's no top electrode, which is technically feasible, but not in our lab. And they are encapsulated using all the right materials. So that means actually all the layers that are in there, need to be in there, are in there, except for the top electrode. On the bottom, you see a mass customized long roll of flexible PV. This is a thin film technology where we did not produce the cells ourselves, but we bought them. And what is unique here is the roll-to-roll encapsulation that we did. And I will tell you a bit more technical details about that in the following slides. So within TNO, what we believe is that every surface can and actually should be used for solar energy generation. And that goes from land to water, to infrastructure, to vehicles. And important for today that we want to highlight is buildings. In the built environment where we use the energy, we should also make the energy. Specifically, if you look at the big assignment that we have within the Netherlands, the production of energy is enormous. And in such a small country as we are in the Netherlands, you cannot just cover everything, land or water or agricultural grounds with PV. You need to come up with smart solutions. We do that in the different topics, but also integrating them into the built environment by means of building integrated PV and dual use of space is very, very important. A small note on the sustainability of PV. If you look at photovoltaics currently, it is renewable. It's known as a renewable energy source, but it's by far sustainable, especially if you look at the current market situation. The demand, but also the production of PV has exploded in the last years. And as you can actually see in the graph on the right side, the CO2 footprint of PV panels that are produced, which is mainly crystallized silicon currently, has risen and risen only in the last years instead of being reduced. So there's something that we need to do there. And also on the recycling part, there's a big job to do. And we all want to do that within preferably the 1.5 degree C rise temperature, global temperature rise scenario. If you look at the carbon clock that is on your screen, this is a screenshot from last Thursday. And you can see we only have a bit less than 5 years left. That's not that much. And if you want to have energy supply fully done with PV, more than 20% of this carbon budget is needed to actually make this happen. That's way too much. So as our former colleague Wim Sinke used to say, we need to go back to the drawing board. Back to where we started, look at what materials we can use, should use, and what we absolutely should avoid using. So looking at critical raw materials, looking at the CO2 footprint, and looking for recycling. So recycling of the current standard, but also design for recycling. And if you want to know more about that, we hosted a webinar in November last year, which can also be viewed back from the website, where my colleague Martin Speet explains a lot more on this topic. What we do at TNO is doing technology development, as I said. So the technology development for building integrated PV are things beyond currently produced in the market. Where we look for integration, so either integration using roof tiles or facade elements, art-like facade elements. So there's sort of two flavors in that. So either looking at aesthetics, we want to make them seamlessly integrated into the building, so you cannot actually see that you have a energy-producing facade, or there's some aesthetics to it where we want to express that there's PV in the facade. So there's mainly two different flavors there. And looking at the technology, the flexible, the lightweight, integration, local production, technologically, it's all feasible, it's already possible. But if you look at the examples in the pictures, these are all handmade, one by one. And that's, of course, not the vision and strategy. As Roel already said, the costs need to go down, which means more automation. And roll-to-roll production is one of the aspects that can play an important role there. So if we look at the future of PV technology in the built environment, in this case, it's visible from nearby, but invisible from far. So you can see my colleague here looking over some mass customized rolls of PV. So these are very, very long, non-standard modules that are made with flexible, lightweight materials, so that have a small CO2 footprint. There's a reduction of critical raw materials compared to standard PV modules. And recycling can also be easier. And that's also one of the points that we focus on in technology developments. Paul already shortly mentioned the Innovation Coalition in Brabant and trying to build the future of PV manufacturing in Brabant. This was signed about 2 years ago by TNO, the province of North Brabant, and the BOM, where the idea is that we set up together in Brabant locally the production, or currently the local production of PV being perovskite in roll-to-roll fashion, and mass customization that will make seamless integration into all sorts of elements possible. So we will try to combine all the aspects from the technology to the economics within this coalition. This you've already seen as well. This is what a blueprint could look like, building the PV manufacturing in Brabant. So this is together with the province of North Brabant and the Solar and Health Growth Fund, where with a lot of partners we all work together getting things done. From a technological part, of course, by TNO, in between the universities and the academic world and the companies on the other side. So I will explain you a tiny bit more about the first two parts, because integration into the other parts is either covered by our friends here at the table or in a different webinar. So building the future of PV manufacturing in Brabant, focusing on roll-to-roll perovskite and mass customization of what we call semi-fabricates. That means what comes out of that roll-to-roll machine is not per se a full module, but can be either cut or sliced, or these are materials that can be integrated into other products, such as building elements, as mentioned by Aldova. So the role of TNO here is really development of these technologies and innovation and development on industrially relevant scale, without actually becoming a producer ourselves. I think that's important to mention. Looking at the perovskite part, there's a lot of advantages and potential advantages that perovskites bring to the table. And one of the main aspects is the roll-to-roll manufacturability of this material. So these can be ink coatings, which means that like printing a newspaper, you can achieve high speeds, high automation, and in that way have mass production. If we can afterwards cut these into smaller pieces and make them customizable, well, that's why we think we have a win-win with combining the roll-to-roll manufacturing of perovskite with mass manufacturing of PV semi-fabricates. This is an example. This is a viewing inside of our clean room, where we can see a couple of my colleagues working on the roll-to-roll coatings. This is really still technology in development, improving specifically on a few topics. So together with partners, we do that. We develop these wet coating techniques mainly, but also the drying of these wet coatings and other deposition methods. As I mentioned, the top electrode is something which cannot be currently done by a wet coating technique, so that's a development still ongoing. Everything is based on PET foil using green solvents, so also their sustainability is very much in our minds. Then for the next steps, well, the top electrode layer, obviously, but also the series connection between the cells, which is more of a technological aspect, but also encapsulation and protection from the environment, so to protect the PV materials from wind and water and temperature and everything. And also recycling strategies. So design for recycling is important here as well. If you want to know more details on perovskite PV and the approximate status at where we are right now, you can view back the webinar from November, where my colleague Sjoerd Veenstra also shows a very nice movie of roll coating of a perovskite layer. Then I'll move on to the other unique piece of equipment that we have, which is called the mass customization line. So together also here with equipment builders, mainly MAN and Duflex have organized parts of these machinery and equipment where we produce these large foils. And we really do this with a research point of view, because this was never shown before. Nobody has ever done this. So it was always either sheet to sheet. Well, it was always sheet to sheet, actually. And what we see here is we are currently still working on the first generation using CIGS cell material, which is a flexible, lightweight, thin film PV material. And we make modules that are customizable with shape and size, electrical output, these things, but also the layer stack, where we can think about having a weathering protection layer on the outside if there's nothing that is added to the structure, but also to leave that out if we want to glue them inside of a frame or onto a steel foil or onto a facade or behind a plexiglass or behind, well, you name it, it's possible. There's also second and third generations planned, and they lie a bit further ahead in the future. But definitely the third generation, most important for here, is the integration of perovskite in this line. These are some of the unique features that the line has, which is pick and place of components. We can use bypass diodes wherever we want, if needed. As I said, freedom of design. We could also include, for example, aesthetic foils on top to already add color to the laminates, make different appearances, and the whole idea behind it is the customizability. And the rolled lamination, which is very important, but also very difficult, because roll lamination means that there's speed, there's time, there's temperature. Basically, we try to glue all the layers together, and that needs time and temperature, which we try to minimize using this roll-to-roll. So that's where the technology development of TNO is very important. The next generations of the line, we will enable back contacting of cells, and we will try to use generic design to be able to use all different PV technologies that are out there, ranging from crystalline silicon all the way to the other end of perovskite PV, and who knows what is next in the world. Something about the status. the current status that we have a baseline to do actual production. There is a specific bill of materials that we have that we call our standard. It's customizable, and one of the things that we are really looking into, which has to do with the roll lamination, is the lifetime of the product in the end. So you see a graph here where in blue there's the average of the MCL, and the MCL is the mass customization line. And we've compared that to what we can do on a sheet-to-sheet level. So sheet-to-sheet is relatively high temperatures, encapsulation, and then we look at how the PV degrades over time. And you can see that we are getting very close to what is standard from sheet-to-sheet in the lab. The gap is not zero, so that's our goal of fixing that first. And the next steps are, design for recycling, because this is not included yet in the current bill of materials. But also here we can think about different addition of different materials or different ways to put them together to be able to do recycling in an easy way at the end. Then I come to my last slide. So looking into the building the future of PV manufacturing in Brabant, TNO really wants to play the technological role here, where in the end, PV will just be a functionality of your building. Try to make PV available for every surface, and we try to do that by the approach of mass customization, together with all the different partners in the different, using different subsidy schemes. And if you're interested, please let us know. Contact us at TNO or at the end of this webinar through email, or the BOM, of course, as Paul mentioned. Please let us know. Oh, before I go to the thank yous, which are also, of course, very important, I do have a number of questions on my screen, actually quite a lot. So thank you very much for your interest and being here with us. Let's see. Paul, I have an interesting question for you. What about collaboration with battery companies to ensure that you have local networks and not a further load on the network distribution?
Yeah, that's indeed a very good question. Grid congestion is, of course, an issue in our province. Also, my colleagues from Foreign Investment are fully aware of it. And indeed, I'm also project leader for the Innovation Coalition on Hydrogen, and another colleague is working on batteries. And you see both on application, but also on the technology, there are overlaps. Of course, TNO is working on thin film batteries. The thin film equipment in our region that could be combined, also perhaps on the production and the demonstration side. And on the other hand, and that's my colleague, it's a real hot topic, what we call the smart energy hubs. So I see, as Ronald also mentioned, of course, we should do local for local. That's a local production of energy and local usage. And then you need the batteries, but also the cloud management systems that you combine the storage, but also the usage of the production directly, if possible. And there the energy management systems combined with the physical installations should be combined in a smart energy hub. And we are doing right now some first pilots, and I think that this will be the future.
I can add something on it.
Well, let me go there. Thanks, Paul, for mentioning also a bridge to the next question, which is for you, Ronald. So then you can also make your other point, because I think this is connected. Thank you. So the question is, why not a proof of principle, Ronald, by realizing an energy hub on an industrial area where builder, BIPV, government and energy company together show the feasibility, technically, economically, socially, of energy independence during all seasons?
Technical, I think it is possible, because Roel mentioned something. You can harvest your cold, your heat, also your sustainable electricity. So everything is there. So you can build a positive energy district. And is it for an industrial site? I think it's even easier than to do it for residential buildings. So I think it is possible. Only the business case is always an issue. And that's in the regulation. So the network parties and so everybody on the table should step up. And now regulation is looking in your mirror, and you're looking at yourself, and you must look open for everything and everybody on the table. So you need the network company, you need the government, you need the owner of the energy, but also the producer and the consumer, and then you can make steps. Therefore, you need now, the new energy law is maybe in the first step.
So why not the proof of principle is first we need some laws
Yeah.
to actually motivate people.
Yeah. In the past
look
we
at
had
the
it,
economics.
but, yeah.
Okay, clear. Thank you. Let's see. There's also an interesting question about the TRL level of the thin film laminates. The question is a bit longer, and there's multiple questions in it. So I'll just answer the main question that within TNO we work up until a TRL level of 6, which is also needed because we need to do technology development. So the mass customization line that you see is a first of. It's a proof of principle. There's still errors in it because at some point you need to make decisions for investments, and that's also the reason why TNO does this and not a company with venture capitalists, because that would have probably been killed already. So that's where TNO plays their part. So the higher TRL level is really the next steps. Let's see if we can have a nice extra question. Here. What is the power per square meter of the laminates? Well, I guess that's a question for me. So the power per square meter is the same as is for conventional PV, but it really depends on the cells that you use. So if you make this technology mass customized with crystalline silicon cells that have the same efficiency or have 23% efficiency, then you can make a module out of it that you can do in a conventional way as well. For CIGS, the cells that we buy give an efficiency somewhere between 16 and 18%. So the laminates that come out of the line are also in that range. So there's no difference between sheet-to-sheet lamination and roll-to-roll laminations there. So the efficiency really depends on the cell material. And let's add that. Having said that, there's way more questions also on my screen, but we are running out of time. So I would like to ask you to be a bit patient with us. We are gathering all the questions that were asked and were not answered today. And then we will come back to you with answers via email. And for now, I would like to really thank you for your attention and participation, because one of the most valuable things in life is time. So thank you for being with us. I would also really like to thank all my speakers here, Paul, Ronald, Roel. Thanks for being here. And I would also like to draw your attention to the Sunchain event, where the whole PV community in the Netherlands comes together. It's called Sunchain, 2nd of October in Stadion Galgenwaard. I've taken a sneak peek there, so please sign up for that and see you there. Thanks for watching.